We're now going to move on to our platform awards. And we have 2 of our 6 platform award winners presenting today, and then we'll have 2 tomorrow and 2 on Thursday. And we received many fantastic applications. It was difficult to narrow down the applicants and pick our winners. But I'd like to thank Bob Burno and the platform award winners from 2020 who made up our committee, as well as Laurence Lejeune, our CNSP vice president. And they judged the applications and determined our award winners. So today we're going to hear from Jeffrey LeDue and Gregory Holloway. So our first speaker is Jeffrey LeDue, and he's the managing director of the NeuroImaging and NeuroComputation Center at University of British Columbia, NINC. And NINC is a scientific platform focused on preclinical imaging and microscopy, as well as computation and data analysis. So I'm now going to hand it over to Jeffrey to tell us more about himself and his platform.
Okay, so I'm Jeff. I work at UBC. Very honored to be given this opportunity to speak to you this afternoon. The title of my talk is Community and Resources, Enhancing Collaborative Research by Building Common Tools. So I'm going to try to stick to the outline suggested by the organizers and describe my platform, my role in the platform, highlight some of our successes and the challenges that we're facing going forward. So as Claire mentioned, my platform is called the NeuroImaging and NeuroComputation Center. It's within the Center for Brain Health at UBC. It's a core facility focused on imaging and microscopy, as well as computation and data analysis. The NINC, as we call it, functions in combination with another entity called the UBC Brain Circuits Cluster, which promotes collaboration and the adoption of open science practices. So these are distinct but highly overlapping entities, and you can think perhaps of the NINC as being more related to the infrastructure and the brain circuit cluster as being more focused on the people. So the current state of the platform, we have 17 member labs, over 200 individual members for the past 3 years. We have 2 academic directors, namely Professors Kurt Haas and Tim Murphy, and myself as the managing director in terms of those that are responsible for this. We're very proud of our Data Binge Forum, which is another group of 200 members that are focused on learning to code, data analysis questions, open science practices, training, and workshops. And these efforts are supported by 1 to 2 co-op students and 6 graduate student peer tutors through Slack and Zoom. We've helped and supported over 130 trainees in learning to code. And last year we saw 12 papers across 9 labs directly supported through this Data Binge Forum and had 778 participants in our workshops. In terms of the resources, the current state of things, we have 7 imaging systems. These are mostly laser scanning microscopes. We have computing offerings, including 8 high-end GPU-enabled workstations for machine learning applications. And we have a small compute cluster running a Jupyter Hub. We have equipment for tissue clearing and expansion microscopy from Life Canvas, and we provide a makerspace for people to fabricate parts to use in their experiments. We have had recent success with CFI proposals, and we are expanding to add new tools to investigate brain circuit functions at new spatiotemporal scales. So in the near future, we will add 8 more imaging systems to the NINC, including ultra-wide field of view 2-photon mesoscope, a 3-photon microscope, fiber photometry systems, functional ultrasound imaging, and a lattice light sheet microscope for imaging of expansion microscopy samples. We will add new compute and storage resources to the Compute Canada CEDAR system at SFU, and we are thinking about increasing our staffing. So I just wanted to give you a flavor of these techniques that we're adding to the NINC. So the ultra-wide field of view 2-photon mesoscope is an instrument that will allow us to image activity across cortical areas during active behaviors, a much larger field of view than standard 2-photon microscopes. A 3-photon microscope will allow us to image circuits that extend into deeper structures in the brain. Over 1.4 millimeters has been demonstrated by other groups. And it's also possible to image through the intact skull in a less invasive manner that's useful for imaging processes involved in interactions between the immune system and the nervous system. The functional ultrasound imaging will allow us to image whole brain networks in awake and possibly freely moving animals. While the fiber photometry experiments can connect brain and behavior in freely moving animals and potentially allow for closed loop experiments where stimuli are fed back to the animal based on their performance and tasks. It's our hope that these experiments would be followed up by nanoscale histology by using expansion microscopy and imaging on a lattice light sheet microscope. So what is my role in the platform? When I joined UBC in 2010, the NINC did not exist. I founded it based on my experiences working at UC Berkeley, where there are so many productive cores in close proximity. So this early period of 2010 to 2013 saw me advocating for the creation of this core. We eventually got the green light in 2014 to go ahead, secure space, plan renovations, relocate equipment, and incorporate existing equipment into the new core. 2017 was when we first collected fees and began our close association with the brain circuit cluster. 2018, I started writing CFIs, which were successful and are leading us to this period of expansion that we're currently in. And I'm looking for interesting opportunities to share resources across the country throughout the remainder of this decade. So the evolution of this has involved a lot of people over the years, and I think my role can simply be summed up in that it was my job to manage the relationships between all these people that made this possible. So the successes that I'd like to highlight, we have a strong and well-supported community through this Data Binge Forum, which is allowing us to undertake larger and more collaborative projects. We've secured 2 more years of funding for the UBC Brain Circuits Cluster. We've had success with CFI, and we're going to be adding these new imaging modalities, which will allow us to contribute new data and new insights to our collaborative projects. We're very excited to again be involved in the Canadian Neurophotonics Platform, Optogenetics and Vectorology Foundry, which provides reagents that underpin most of the experiments we want to do in the NINC. And we've seen success with engaging with international network of networks type things with our partners at University of Washington. This is something called the International Network for Bio-Inspired Computing, which connects experimental and theoretical neuroscience. And this is mainly coming from our emphasis on open science and research data management. In terms of challenges, I just wanted to highlight something that we actually chatted about in the breakout rooms before my presentation, which is the sustaining and building our online communities that we've developed during the pandemic as we head back to work. So will we be able to continue to take advantage of people's willingness to hop on these Zoom calls? And my hope is yes. We're looking for ways forward for our peer tutor models through perhaps the Canadian Open Neuroscience Platform or the Canadian Brain Research Strategy, or maybe even Endrio. Another challenge with the new instruments is that they will be used in highly complex and demanding in vivo experiments. And so at the moment, I'm putting hopefully the right amount of effort into creating standard operating procedures and protocols to make this as smooth as possible when the instruments start arriving at UBC. Sustainable growth is not unique to my platform. It's a concern for us all, but it's something I'm definitely thinking about. And on a more personal level, I want to ensure that I can continue to make meaningful contributions to research projects in the midst of all of this, activity that we have going on at UBC. So with that, I wanted to acknowledge the past and present co-op students that have worked with me. This is Ashu, Glenelle, Annika, Carlos, Ashley, and Keegan. Our graduate peer tutors from DataBinge, Abhijit, Pankaj, Peter, Adrian, Nick, and Jordan, and all the students and postdocs who have helped me co-organize events over the years. And finally, the NINC academic directors, particularly Professor Murphy, and the DMCBH directors, past and present. And with that, I will take questions. Thank you very much for your attention.
Thank you very much, Jeffrey, and congratulations on the award. So we'll move on to our next Platform Scientist Award winner, Gregory Holloway. And he's an electron beam lithography scientist at the Quantum-Nano Fabrication and Characterization facility at the University of Waterloo. And he's going to tell us a little bit about himself and his platform. So please go ahead, Gregory.
All right, thank you for having me here and giving me a chance to share what we work on here at the Quantum-Nano Fabrication and Characterization facility. Today, I want to be talking about the power of scripting and expanding tool accessibility and function. So I feel it's very appropriate following Jeffrey's talk, talking about all of this coding and learning coding. I'm a big supporter of that. But first, a bit about our facility. We're located at the University of Waterloo in the Mike and Ophelia Lazaridis Quantum Nano Center, which I'm showing an image of here. What we do as a nanofabrication facility is help users build their devices all the way down to the nanoscale is what we try to do. So devices like this, we kind of operate like a traditional nanofab that makes the normal semiconductor devices that you think of today, normal computer chips, but we offer a much wider range of tools, materials and processes to allow for novel fabrication, devices that you wouldn't get in a normal fab for kind of cutting edge research. With this, we support devices for quantum computation, microfluidics, the nano mechanical sensors, all kinds of different things, kind of whatever people want to build, we want to help them make it. Our main facility is an 8,000 square foot clean room shown in these pictures here, but we also have several other satellite labs across the campus. Our team is composed of 13 members, and our big focus is on user training and user tool operation rather than service work. We want to give people the knowledge and experience they need to operate these tools rather than having us operate them for them. We want them to make their own devices and us guide them through with our experience in getting the devices they want. We have 288 active users, and we have these users have logged over 32,000 hours on this equipment in the 2019-2020 fiscal year, and this number continues to grow year after year. These users come from research groups at the University of Waterloo, but also companies and research groups across Canada. My role at the facility is an electron beam lithography scientist, or more generally a lithography scientist. And what that means is I help people perform lithography. I help them design their patterns in specialized CAD software. So kind of a device that might look like this, and then use the lithography tools that we have to literally write those patterns onto a substrate. So going from the software design to the real device there. Our lithography tools fall into two categories: UV lithography tools, which use ultraviolet light to write these patterns onto the sample, and they can kind of get to resolutions down to 1 micron, and E-beam lithography tools, which can go down to 10 nanometers, which use a focused beam of electrons to actually write those patterns. My role is for training users to operate these different types of tools, developing new processes on them, and general equipment maintenance. I'm also a really big fan of computer programming, and what I want to talk to you about today is some scripts that I've written to make operating these tools easier and to add additional functionality that they wouldn't have had originally. The first thing I want to talk about is our electron beam lithography software. So that electron beam lithography tool I showed you on the previous page is our JL6300. And it's really a fantastic electron beam lithography tool. It operates at 100,000 volts to accelerate electrons down to the sample. It focuses them into a beam that can achieve a resolution of 8 nanometers for writing patterns. And it can overlay one pattern on top of another with an accuracy of better than 20 nanometers. It has numerous corrections for shaping the beam, its size, its shape, its position, its deflection, to really ensure that we have the optimal exposure. It really is really good at EBL. Its one problem is that its Linux-based software is very clunky and complicated. Not surprising with all those corrections that you can implement. There's a whole suite of menus you have to go through in order to enter in the appropriate values to make the tool operate as you would like. So just kind of a simple demonstration here. Here's our kind of calibration menu, and you can open that up to get all of these different fields where you can enter values in, and beyond that, there's further sub-menus with more fields and more menus that you can go through. And for new users of this tool, this quickly becomes overwhelming trying to navigate through all of these different aspects of the tool. So my solution to this was to write a Python script, which I call Calibration Plus, to make operation easier and faster. The script literally walks users through all of the operation steps of using the tool, and it autonomously selects the appropriate procedures to run based on what the user wants to do and how the tool is operating. So to kind of give you a demonstration of this, I recorded myself operating the tool, just doing one specific part of the procedure, which is the alignment procedure, and I'm going to play it for you now at 10 times speed, just to give you a sense of me sorting through all the different menus on this tool, entering the different values, going back and forth between this desktop and another desktop, and recording values and updating everything, just to show you how complicated and time consuming this one part of the process can be. And for someone like me who's operated the tool for years, going as fast as I can, this one step takes about 4 minutes. But for a new user, it can be many times longer than that. Whereas with the new script that I've written, it's significantly faster. There are a few things to enter, a few things to look for, but overall the script is much easier and only takes about 40 seconds to run. An over 5 times improvement for me, but likely much, much faster for other operators who are just getting started with the tool. And what this means is that it makes the tool a lot easier to operate. It allows people to focus on the complex electron beam lithography process itself without having to learn about learning complicated software, really focus on the process rather than the tool itself. This lowers the barrier to entry for the tool, making it much more widely available. We can allow a broader range of people access to the tool this way, and it makes the tool faster to operate so that we can get more exposures in a given day. Just to kind of quantify that, why I counted up how many exposures we ran per month just before our COVID shutdown, and it was about 64 exposures per month on this tool. I introduced this new software at the end of 2020, and then in the last few months, we've been up to over 90 exposures per month. So a pretty clear increase in the throughput of this tool with this new software. The other thing that, another example of where we're using scripting is actually to enhance the functionality of our tools to give new modes of operation that weren't there with the tool in the standard mode. And with our UV lithography, we can only do binary exposures with this tool, meaning that we can only kind of have 2 levels of exposure, either an exposed part of our resist or unexposed regions. You can see there's just 2 colors in this pattern, the blue and the red, corresponding to those 2 exposure modes. In the cross section here, we can see the same kind of thing. I can only either expose the resist or not expose it in the traditional exposure mode. There's no other options here. What we would really like though is something like this, where we kind of have a 3D structure in the resist, this kind of curve shape you see here, or we call it 2.5D or grayscale exposure, where we kind of give it a half exposure in this region to get this curved shape. Another example of this is this blaze grading I'm showing at the bottom here. So this is a diffraction grading where we've slowly varying the height of the sample in between the pitch of the grading. And this gives us a much higher efficiency diffraction grading, which is another device that would be nice to fabricate with this grayscale exposure. These curved structures would be better for microfluidics, would have kind of less turbulence than these binary exposures here. So that's kind of a motivation of why we want to do this, but how do we actually make it work? Well, the problem is the UV power in the tool is fixed. We can't say expose with one power here and a different power here. So how do we accomplish this grayscale? Well, the idea is to use a varying pattern density to achieve this. And so I kind of came up with this idea from classical lithography, classical printing with the halftone printing. So this picture of my cat here is only drawn with black and white dots, but by varying the size of those black and white pixels, I can approximate gray tones to your eye, kind of with these sub-resolution features. So you can see in the zoom in here, the smaller black and white shapes approximate the gray features in the ear of the cat. We can do the same kind of thing with this lithography. So here is a user pattern where we have the dose or the power of the exposure varying indicated by the colors here. And with this Python script that I've written, we can convert this power or dose variation into a density variation of the pattern. So you can see after the conversion in the bottom here, everything is that one uniform dark red color. but there's a variation in the actual density in this region that matches up with the power variation that we wanted to achieve in the original power pattern. And when we expose this, sure enough, we get kind of what we'd expect, these little hillock structures that have a slope to them that's determined by this variation in power that we saw there. And so while this little example works well, I wanted to kind of test it on a larger scale and give something that would give a better indication of how well this is working. And so I created this device here. So this is a microscope slide that I've patterned with this kind of ring shaped structure here. And if I zoom in on this, you can see it's actually composed of a whole bunch of little squares. And further zooming in, you can see these little squares that are 10 microns wide are actually varying in height relative to one another. And while this pattern looks completely random here, it's actually a computer generated hologram where I've intentionally made this variation in a specific way such that when light is shone through this structure, the light acquires a variable phase from each of these different squares. And if it's designed properly, they all add together to give a constructive image out the end of the device when we shine the light through. And sure enough, when I shine a green laser pointer through it, we get this simple vision of our logo here, which is great. But not only that, in this ring, I actually created many versions of this image. And so when I move my laser pointer around the path of this image, it actually causes the logo to spin around. So I think this is a pretty good evidence of the effectiveness of this grayscale exposure in generating this kind of diffraction image effect. So to conclude, I demonstrated some ways, a couple examples of how we use scripting to expand our tool functionality, kind of making our electron beam lithography software easier to use and adding new functionality to this grayscale or 3D exposure to our photolithography tools. I just want to kind of reiterate the fact that I think these scripts can be very powerful. Even simple scripts can do a lot. Initially, my jail script just kind of copied over some data from the user files over to the tool, and I built upon that over time to make a more and more complex and robust piece of software that kind of did everything for the user. So I hope this has been given you kind of a glimpse of what we do at our facility and how we use scripting to improve our functionality. Thank you.
Okay, thank you very much, Greg, and congratulations again on the award. It's really nice to see how you're able to be creative there in the different ways that you use the lithography to gain the functionality you need with the tools you have. I wonder, with your scripting and that, how do you choose which instruments or which problems to tackle first? Do you have like a wish list from users, or do they kind of, are they quite obvious and float to the top and you know exactly the next one you'd like to tackle?
It usually comes from me kind of operating the tools and seeing what users say. They don't necessarily request a specific feature, but I see, oh, people are really struggling with this part. It'd be good to make it easier for people. So
it's your observational skills, seeing where the bottlenecks are.
Yeah. I mean, if I sit with people and train them, I have to go through it many times sometimes of, oh, this is clearly the bottleneck.
Right.
It's for my own benefit, if nothing else.
Sure. And I guess my other question is kind of related. It's very busy, like in training and probably maintenance and all these other things. How do you find time in your schedule to carve out to focus on programming and
I just try to be efficient and yeah, you use those times throughout the day, kind of block off a certain time for training and another time for working on this stuff, and just try to get done what I can.
So you find you can carve out a couple of hours here and there, and
yeah, exactly, and just slowly build on it. Like I said, it develops over time, right? So.
I know for my staff, it's sometimes difficult to get the stretch of a couple of hours where you can actually get your mind into the task at hand and get working on it. But it's very valuable if you can do these things, which are seem fairly small, as you say, but can really save people a lot of time and effort, and they can focus on the science rather than the process, I guess.
Exactly. Yeah.
Excellent. I have a question here from Chris Law. How supportive were JEOL of your work automating the software?
I actually haven't shown them this most recent version, but I've kind of shown them bits and pieces along the way, and they really appreciated it. And they've actually taken some of these ideas to put into their future tools. So it's they really like it, and they try to encourage more people to do this kind of stuff, but there isn't always such a big uptake.
Is there a chance to feed it back to them and actually have them provide it to other users, do you think?
Yeah, that's the goal is yeah, to do that, to get it to be fed back and more widely available.
Excellent. Okay. Well, thank you very much for your presentation, and congratulations to you and to Jeff. It's great to see the wonderful work you're doing to support the research community.
Thank you.
Alors, bonjour à tous pour cette deuxième partie. Thank you everyone for being here for the second part of the day. So my name is Laurence Lejeune. I'm the Vice President of the CNSP. So I'm very, very happy to present to you. Je suis vraiment très fière et heureuse de vous présenter aujourd'hui deux personnes qui ont gagné le prix des scientifiques de plateforme pour Mathieu Durand et pour Valérie Villeneuve, administrateur de plateforme scientifique. So I'm very proud to present you today Mathieu Durand and Valérie Villeneuve, both award winners. I'm very impressed by the work that has been presented to us throughout this event. So to paraphrase Guy Lévesque, it's not that easy, but we still manage to do great things in scientific platforms. So first, I would like to introduce Mathieu Durand. He's from the RNomics platform at Université of Sherbrooke and provides a wide range of genomic services with special expertise in the detection of RNA variants and high throughput prints. So I will now hand it over to Mathieu.
So thank you very much. My name is Mathieu Durand, and today I will present you the RNomics platform of University of Sherbrooke. First thing first, I would like to mention that I'm very grateful to have been chosen from among excellent candidates. So I will also like to congratulate everyone and the other 4 winners. So the RNomics platform, the beginning, the platform was founded in 2006 to provide a wide range of genomics services with special expertise and in the detection of RNA variant and high throughput screen, was founded by Genome Canada and Genome Québec. Now the team member, we are a little team, but a good team. So we are 4 research professionals and a scientific manager. It's Professor Sherif Abouelela. So LV lead the NGS part, Sam quality control and project development, Phil it's our bioinformatician, and me, my role in the platform is research professional. Maybe 70% of my time I am on the bench, and 30% of my time I try to manage some stuff for the platform. So some numbers. We have about 150 research institutional and pharmaceutical clients from about 45 institutions from 10 different countries. That leads to a huge number of collaboration, grant support, and publication for our clients. So the core, the services, so we provide all-inclusive services from the design stage and assistance with grant application to data preparation for publication. So the services is like, for example, isolation and quality control of nucleic acid. We have 2 Magna per 96 extracted robot that's lead to high throughput extraction of RNA, DNA from cell or tissues. Sure, the RNA integrity is very important. So we have capillary electrophoresis technology like the bioanalyzer or GX2 Touch 2 from PerkinElmer or Caliper. So other services, it's next gen sequencing. So the preparation of library for the detection, for example, of poly-A, structure-A, non-coding, ribodepleted RNA. amplicon-based library using Illumina base, and more recently, Tiger-seq. And all of that just leading DNA-seq, RNA, chip-seq, small RNA, PCR amplicons, metagenomics like microbiome, right? Microbiome with 16S, and more recently, single-cell sequencing. So all of that, we offer a sequence throughput variant from 15 millions read up to 40 millions read on our two platforms, MySeq and NextSeq 500. Simple pooling and link sharing are also available. Last week, we just received a minion from Oxford Nanoport. It's good for a long read, maybe 50 gigabytes per flow cell. It's user-friendly, low cost, rapid turnaround. So this is the next-gen sequencing services. Sure, we have the gene expression and transcript quantification services. All of gene expression by qPCR, CyberGreen, or either a probe TACMan. We do multiplexes. We have a lot of Bio-Rad CFX Opus 96, like 5 and 384, the same things, 6 or 7. So that leads a lot of it's high throughput screen we can do up to 8,000 PCR per day, reaction per day. We have a pathway specific screen for gene expression and splice variant. Absolute quantification of gene expression, direct transcript comparison and ranking, direct contamination independent assay of gene expression in clinical sample. All of that is on ddPCR from Bio-Rad again. We have two QX200. And we have a niche in Sherbrooke. It's the detection of alternative splicing event. So we do the calculation of splicing index using endpoint PCR coupled with microcapillary electrophoresis, so ASPCR. So if you want to check the two isoform in the same reaction, long and short, we can do that. Sure, we do a detection of microorganisms by PCR, qPCR, ddPCR, and sequencing. It's from mycoplasma contamination up to animal facility pathogen. Microbiome profiling using RNA sequence. Multiplex and high throughput viral screen. For example, SARS-CoV-2. I will talk a little bit about that later. Finally, DNA-based tests like genotyping, plasmid copy number, and for sure we have a bioinformatics support. So all the services are of the platform come bundled with basic bioinformatics support from primary design to primary data analysis. But now Phil just leave opportunity, so all of the meta-analysis and in-deep data mining are also available. Oops, sorry. Are also available through our University of the Sherbrooke computational platform partner, led by Pierre-Étienne Jacques from Calcul Québec. So in summary, we are specialized in the low-cost, rapid turnaround, mid-throughput transcriptomic screen, generic and specialized library preparation for whole transcriptome, splice variant, RNA non-coding sequencing, integrated computational and robotized PCR amplification pipeline for high-throughput screen, RNA quantification absolute with ddPCR, and splice variant detection using endpoint PCR. Finally, the latest success story for us, it's SARS-CoV-2 detection, PCR detection. So we offer automated rapid tests for viral and bacterial infection using the highest standard and clinical practices for research purposes. RNA is extracted using robotized platform, quality control and data are accessed in real time using secured and personalized database access. So University of Sherbrooke at the heart of the fight against the COVID. So I'm very proud about that. we have kind of pioneer in this detection test. In early March 2020, we established our homemade master mix called Sherbrooke 20 to help hospital because like everyone know, hospital, our center of detection had a lack of reagent at the start of at the beginning of the pandemic. So we rapidly we do that and help some hospital in Quebec. So a lot of collaboration with hospital, universities, and Quebec Institute in order to share our know-how. All of that is we do the 4-plex detection test with a human control against RNA and 3 very sensitive SARS-CoV-2 target. And all of that is mix and match. So I developed a lot of multiplex targeting a current variant. So UK, Africa, India, etc. And I can couple with influenza A and B and RSV for example, in fall season to do the discrimination between SARS-CoV-2 and influenza. So all of that lead to a good CFI and MEI grant and some publication about that. But the take-home message and what I'm most proud of that is the historic agreement between the Université of Sherbrooke and the hospital worker. This agreement between CSU and the platform lead to permit to perform to us 400 to 800 daily screening tests for the public health industry. So with that, we just help the hospital to get the tests done for the population and to keep it in 24 hours for the people that wait for his result. So it's very nice for us. And all of this partnership will soon lead to a numerous collaboration with several physician researchers for variant sequencing project, detection, etc. So that was the RNA platform. So thank you all for your attention and have a good end of day.
Going to introduce our next speaker today. Je vais vous présenter Valérie Villeneuve du CHU Sainte-Justine. So Valérie Villeneuve won the Administrator Award for her role in consolidating and developing scientific platforms at the research center at the CHU Sainte-Justine, so l'hôpital pour enfants Sainte-Justine, based in Montreal. So Valérie, the floor is yours.
Thank you, Laurence. Good afternoon, everyone. First of all, thanks to the CNSP for having me this afternoon and giving me the opportunity to present the scientific platforms that we have at the CHU Sainte-Justine Research Center. Prior I start, discussing about the platforms.
Valérie,
yes.
Can you put in full screen mode, maybe?
Okay, let me see.
If that's what.
Is that okay like this? No, it's not. Okay, let me try again. So it should be full screen now. Is it?
It's okay. We see well.
Okay, I can try to
I think it's fine.
make it bigger, maybe like this. Do you see it?
I think it's because it's a PDF file
Okay,
rather than
so,
a PowerPoint.
Okay, let me just try to share again. Maybe that's why.
I think it was fine as you had it, but
Okay, because that's the biggest I can so far. I'm sorry about that. Yeah, so a bit about my role and as a core facilities manager and what I do so far. I arrived in 2017 and about 4 platforms, I would say almost 5 here with the microscopy, were currently in operations. And I started to support the operations, and meanwhile, I also participated to create 5 others. And I also you know, how can I say, I bring inputs into development of those platforms as well, following the strategic planning. And I also enter a solid liaison with the various partners and collaborators. So we have right now about 10 platforms with 16 scientific directors involved, and each platforms have a scientific committee where I'm part of. I have a scientific background as well, so it's easier for me to understand what is discussed about science, but mainly we discuss about management. We have about 250 researchers that we deserve and over 500 users. And as it is a teamwork, we have 13 platform managers. We can see a part of them. That was a last minute pictures taken 2 days ago, so there were people missing. We have also 4 technicians for a total of 18 people. So as you may know, Specialized Platforms is a platform that offers comprehensive services with an application specialist. And we have namely the microscopy platform, the flow cytometry, the IPS platforms, and so on. So I'm going to introduce you briefly to each of them. And we have also the single cell sequencing analysis platforms. So we're recruiting bioinformaticians. So if you know anyone or if you're interested, please contact me. I would love actually to meet that person. So about the microscopy platform, there are 13 high-end light microscopes, 3 image analysis workstation, and dedicated staff as Elke, which offers customized trainings and support. And I'm sure she will be delighted to talk to you a bit more about that during the open discussion this afternoon, because she's attending the meeting with us. The flow cytometry platform has actually 2 cell sorters, 3 analyzers, and we offer up to 4 population sorting. We have high throughput acquisitions as well, and assistance for the development of protocols, optimization, panel designs, and data analysis too. The stem cell reprogramming platform, offers a lot of possibilities. It starts with healthy pluripotent stem cells for reprogrammation. It offers opportunity to study, to recreate pathology modelization, study the mechanisms of pathology, correct imitation, test therapeutic molecules, and can also be used, as I said, from healthy cells from the same donor, and you could also differentiate them, replace the patient lost or damaged cells. So there's many things that can be done at the platform, and we deserve the research teams internally, but also externally for all those platforms. The humanized mouse platform offers a model of immunodeficient mice with a human immune system. We have 6 different strains. It could be used for many different domains of researches, such as use for patient-derived xenografts, pharmacogenomic studies, different models of infectious diseases, could be HIV, Zika, many others. We have a BCL2 environment as well in that platform. As I didn't mention, you could find the information for each manager, but if you are interested to know more about one platform, please feel free to contact me and I will direct you to the proper person. And basically that platform, as the cytometry platform and the IPS one, are funded by the Sherbrooke Cancer Foundation. And basically the funding through the platforms we have are through CFI, Sainte-Justine Foundation, Sherbrooke Foundation, NRC as well, and many others. The genome editing platform offers, through the CRISPR-Cas9 technology, gene disruption, gene correction, gene insertion. We have also an institutional biobank. We are specialized in rare pediatric diseases, but we offer our expertise in molecular and cellular biology, could be for COVID-19 research projects as well that we already do. The services are basically pre-analytic techniques would be serum plasma preparations, biospecimen preparation. We have a robotic station, so we do offer DNA RNA extractions, and mostly for the COVID-19 research projects, we do a lot of PBMC isolation, which is about almost a quarter of the work distribution. And you can see here we have a room dedicated for about 20 -80 freezers, and we have 4 big cryocubes for nitrogen cells preservation as well. And finally, the mass spectrometry and pharmacology research units are 2 different platforms, but they both work in close synergy, because the mass spectrometry platform is more fundamental and work more on translational researches, but the pharmacology platform do more drug dosage. However, they both offer consultation and method development. And what is particular with the mass spectrometry platform is that we have a arbitrary eclipse frames, which there are only few in Canada about arbitrary eclipse, and I think we are the only one in Sainte-Justine with the FAMES module. And the pharmacology platform has the triple quad. And we are also currently recruiting for the position of the manager. So if you know someone which is very good in mass spectrometry and likes pharmacology, please feel free to let me know. And a short word about successes and challenges in those platforms at Sainte-Justine. I would say that successes are that toward the course of about 5 years, we saw stabilization of in the number of users, and some of them at increasing number of users, which is a good news. We could also saw an increase in requests for external PIs. So I think by the word of just mouth, people start to know more about what we can offer, and we get a request for new research projects. We reach our aim in terms of cost recovery, and we also launched the first edition of Symposium of Innovative Technology in 2019. Unfortunately, the 2020 edition was canceled, and I'm still thinking about the 2021, and a part of me would like to do it, with people around us at Sainte-Justine, so not sure it's going to happen. And we created as well in 2018, if I'm not mistaken, a web portal for management and usage. So it allows booking, invoicing, giving access to when a person is properly trained. So it's very useful either for the managers and the users. And few challenges, I won't go into details about that because it has been widely discussed this afternoon, but staff recruitment and retention is a big problem, funding for sure, and equipment replacement, yes, because of funding, but also because of the Quebec legislation phase of the law and the public tenders, it creates delays and reduce our competitivity. So that's a challenge for us. And I would like to finish by saying that the Sainte-Justine Research Center platforms promote collaboration and partnership between research teams. And I would invite you to go visit us at shusj.org. Thank you very much.
Hello, everybody. Welcome back, and thank you for joining us once more. My name is Brent Myron. I will be your virtual host for the last sessions of the 2021 SPM meetings. I'm the CNSP Eastern Canada representative and the director of the Office of Strategic Institutional Research Initiatives at Memorial University of Newfoundland and Labrador. So we will now be beginning a presentation of the Platform Awards, the remaining Platform Awards, as you can see on the screen there now. Thank you to all of you who submitted a nomination, and congratulations again to the 2021 recipients. Our final 2 award recipients of the Platform Awards are Pearl Campbell and Sharon Curtis, both from the University of Ottawa. Our first presenter will be Pearl, the recipient of the Platform Director Award. Pearl Campbell is an investigator for in the Regenerative Medicine Program, Director of StemCore Laboratories at the Sprott Center for Stem Cell Research at the Ottawa Hospital Research Institute. Over the past 2 decades, the field of genomics has rapidly evolved, and new technologies are allowing the scientific community to address questions which were heretofore unfeasible. During this presentation, an overview will be provided of the history and operations of StemCore Laboratories, a genomics core facility of the Ottawa Hospital Research Institute and the University of Ottawa. Projects in which StemCore has played a role will be highlighted, and the challenges for a mid-size academic core facility to keep pace with emerging technology will be discussed. Welcome, Pearl. The floor is yours.
Thank you very much. Slides, please. So I want to thank the nominators and the selection committee first for choosing me as the recipient of this award. I'm greatly honored by it. I'll try to share mine. Let's see if this is going to work. Okay, can everybody see my slides?
Now we can, yes.
Okay, perfect. So I want to follow the outline that was given to us for the presentation. So I want to go over the history of StemCore, operations, platforms, and services that we offer, and then overview some challenges and some successes that we've encountered along the way. So StemCore began in 2002. It was the dream of Drs. Ronald Wharton and Michael Rudnicki to start a genomics core facility in Ottawa. The first large-scale project that really provided for the infrastructure within StemCore was the Stem Cell Genomics Project, which was done in collaboration with the Stem Cell Network, which is a network center of excellence. It was supposed to end in around 2010, but because of ongoing funding, it still exists. StemCore operates with a dual mandate. First is to support high throughput genomics projects in Eastern Ontario, and then to provide genomics services to the local research community. We are the genomics core facility of OHRI and the University of Ottawa, and have been supported by them since 2009. I was hired in 2002 to start up StemCore, and I've been with StemCore and OHRI since. Startup and continuing funding is provided, of course, by many agencies, and I just give a depiction. CFI and Genome Canada were two of the major sources of funding for our startup and continued operations. We currently have 4 full-time staff and the managing director, myself. We also engage 1 placement student each year on average. Generally, they're from either Canadore or St. Lawrence College in their biotechnology program. We have a lot of equipment which we keep up to date and well maintained. Most are under service contract, and I'll describe the equipment and the services that we offer. All of our work is done with SOPs, which are available to our clients. We have a strong web presence which describes our facilities and our offerings, and we accept online sample submission via Agilent iLab currently, although this will be likely changing this. So the platforms and services that we offer are Sanger DNA sequencing, single cell analysis, and next generation sequencing. For DNA sequencing, interestingly, we were the first facility within Canada to have a 3730 in place. And it's interesting and ironic because when we were starting up StemCore, it was actually during SARS in 2003, and we were delayed in getting this instrumentation. This year, we've just upgraded our 3730, and it again was delayed because of SARS #2. So that was quite ironic, I guess. We also have offered single cell analysis since 2018. We have several platforms that we can use, including 10x Genomics, Chromium controller. We also have a Fluidigm C1 and a Biomark HD equipment. We offer from 10x Genomics all of their applications. So we do single cell gene expression, we do ATAC-seq, and we're rolling out all of their multi-ohm applications currently. They seem to be quite robust and are being utilized very well in the facility. We also offer next generation sequencing. We currently have an Illumina NextSeq 500 and a MiniSeq in place, but in a new CFI application, we are hoping to acquire a NovaSeq. So you'll see it later in my talk where I discuss how keeping up to pace with technology is really important. And we think that the NovaSeq will be a great opportunity for us to help decrease pricing for next generation sequencing for our current users. We also are hoping to acquire a codex for spatially resolved proteomics, which will be added to our single cell facility in the fall. We also offer flow cytometry and cell sorting. Our facility is operated by an expert operator who has many years of experience under his belt. We started out originally with a MoFlow XDP. However, this year we were fortunate in that we were able to add a Sony MA900 as a walk-up instrument and a BD LSR for Tessa. All of the regular services that you would think of for flow cytometry are offered. Our expert operator also offers quite extensive training for operation of the instruments, analysis, and other features as well. It was very important for us to have flow cytometry as part of our offering because it's the upstream workflow for many of the genomics applications that we provide. So we reside within a stem cell floor. A lot of researchers are interested in profiling their highly rare populations. And so it often starts with flow cytometry before it goes either to next generation sequencing or to single cell analysis. We offered services for over 400 research groups. In the past year alone, I think there were about 220 research laboratories we provided service for, despite the pandemic and the decreased request for services because of that. We provide service for 14 research institutes, 21 academic centers, and so on. So we have quite a diverse population that we service. So I have a very experienced lab that does the bench work. I'm no longer at the bench. My role in the facility really is provide what's on this screen. StemCore does offer end-to-end genomics services, and by that, what I mean is that we will work with researchers for pre-award grant support, doing proof of concept experiments. We'll do technology development with them if they want to try something new. We'll assist with experimental design, implementation of new applications. Also, we'll work with them on statistical considerations, power calculations, and the like for large-scale studies with support from our bioinformatics facility. Technical support is also, of course, provided, recommendations for best practices. Oftentimes, researchers will come to us, clinical or early stage investigators who maybe have a question but don't exactly know what the best technology is. And so it's really my job to work with these people to recommend, either with the technology that we have in-house or even technology that we don't have, to recommend where to go to best conduct the study that they would like to conduct. Our staff is also very flexible with respect to clinical samples. So a lot of the work that we're doing now in single cell come from surgical samples. And so the staff within StemCore is very accommodating to work on off hours to be able to collect these very precious samples. Also, at the end of the experiments, we engage and help with manuscript preparation and other things as well. So the bioinformatics facility that I mentioned, the director of the facility is Ted Perkins. The managing director is Gareth Pallador. Their expertise is in single cell analysis and high throughput sequencing analysis. They've also in the past done microarray. However, that technology has been mothballed within our facility. They also work on data integration of multiple data types, computational modeling, and network analysis. So now I'd like to just discuss some of the challenges that face academic core facilities in general, and our facility in particular. And that is, the major one is really sustainability. And I think I've heard that as a recurring theme throughout the conference. Our fiscal mandate is to maintain revenue neutrality with respect to all StemCore operating costs. So this would include salary, benefits, reagents, consumables, and maintenance contracts. Often, however, this is at odds with our mandate to be cost competitive. And so we do receive some support from our institute and from the university. However, it's really often not enough to offset all of the operating costs that we have. And so if there was a way, work with people to write grants and whatnot to be able to come up with funds to maintain this revenue neutrality. So as well, we have challenges with respect to the bandwidth to support bespoke projects. So if you're a large core facility and you are focusing on one or two major grants and doing the same thing, well, it's very easy to have that pipeline and you just keep doing the same thing. However, if you have projects that are very different, you need to work them up. Having the time to be able to work up these projects and the staffing to be able to dedicate these very bespoke projects can often be difficult for us. So finally, I'd like to talk about some of our successes and long-term contributions. So several Genome Canada projects have run through StemCore, including the Stem Cell Genomics Project. In this project, we profiled multiple cell populations. This has been captured. All of the data that was produced through this project was captured in Geo and is available even now for people to use in subsequent studies. We also were involved with the International Regulome Consortium, where we looked at the transcriptional networks involved in regulating cell fate transitions. So looking at the protein-protein interactions and the transcriptional regulators that control gene expression in the various stem cell types. Currently, we're just wrapping up a clinically based translational project, which is the standardization of molecular diagnostic testing for non-small cell lung cancer. This is a collaborative project between OHRI, TOH, and ERLA, where we are looking at best ways to profile fine needle aspiration biopsies in lung cancer. So, and actually a very positive result so far of this study has been that it has been instrumental in bringing next generation sequencing to Ottawa for targeted therapies in lung cancer. StemCore has over 400 peer-reviewed publications that are listed on its webpage. We also have numerous collaborations that are ongoing for basic discovery and translational research. So some of our success stories include research into Duchenne's muscular dystrophy by Dr. Michael Rudnicki, several studies on blood cancer, chemo-resistant blood cancer, looking at natural killer cells being key to cancer immunotherapy by Michele Ardolino, type 1 diabetes, looking at research in early metabolic defects, and finally, estrogen and ovarian cancer by Barbara Vanderheiden. So the final slide, I want to just overview the inherent value of local core facilities versus outsourcing. So of course, we all here support the local core facility and the value of it, but it really provides support for trainees and early career scientists. It allows project prioritization. So if there are deadlines for grant submissions and the like, we can really prioritize these projects so that the client can have the data in time for their submissions. And again, as I mentioned before, the flexibility of our staff, especially with respect to clinical samples, which really couldn't be outsourced, say, for example, for single cell analysis. There's a very important component for a strong user base for grant funding and continued sustainability. So it's really a reciprocal positive thing in which if we have a strong user base, we're able to provide more services to our users and provide them at a lower cost point. And as well, acquisition and implementation of new applications versus mothballing outmoded technologies helps us. These decisions help us to keep pace with the needs of the local scientific community. So for example, in one of our first projects, the stem cell genomics project, we used SAGE, serial analysis of gene expression and microarray analysis. These no longer are done. They've been outmoded and replaced by next generation sequencing, spatial and single cell technologies and multiomics. And of course, there's the importance of working with researchers on CFIs and other sources of funding to maintain the strength of the core facility. So my final slide, I just want to reiterate that StemCore provides end-to-end genomic services, and I function with a highly trained staff. So two of my staff members, Caroline Vergette and Kathy Sheikh-al-Islami, they've been with me since the beginning of StemCore. Fernando Ortiz is our expert operator in flow cytometry. Then new to the staff at StemCore is Shahryar Sheikh-al-Islami, who unfortunately we weren't able to get a group picture because he started just prior to the pandemic. So that is the end of my slides, and I'm happy to take any questions.
I'd now like to introduce Sharon Curtis of the John L. Holmes Mass Spectrometry Facility at the University of Ottawa. The title of her presentation is, as you can see, Nuts and Bolts of Mass Spectrometry. I like the sound of that. The presentation will look at the many facets of managing the John Holmes Mass Spectrometry Facility, and in particular, having the best instrumentation on the market, the best people to run and maintain that equipment, the best directors, competent professors and students, and interesting projects. I like the sound of that. So I invite Sharon to come on and tell us some more.
Yes, thank you very much, CNSP, for some very interesting talks during the last few days. And it's interesting that we all seem to have very similar problems, and hopefully that some of that will change, and that the funding managers have listened to our criteria, and hopefully some things will happen. So number one is it's important to choose a really good university that values your core facilities, and it was really I want to thank Guy for his involvement in promoting us at bringing us into the limelight at the University of Ottawa. Thank you to the CNSP for choosing me to be a prize winner, and I offer my congratulations to all the other winners too. So, the mass spectrometry facility began in 1964 when John Holmes here, looking very young, was given $56,000 to buy a mass spectrometer for the chemistry department so that they could work out the formula of all their compounds that were made in the organic chemistry department. John ended up running that instrument because nobody else wanted to. And in 1980, Sander Monmouth joined him and became the mass spec engineer, and that's how we all began. So it's important to have really good instruments, and I have a couple I'd like to highlight here. We actually have 11 instruments within the facility, one of those, and a broken moldy. The oldest of which is this 1980s Kratos magnetic sector instrument that you see in the top left-hand corner there. That instrument is the instrument that you learn about when you do your high school education. It's a magnetic sector. The only reason I still have one is Sander Monmouth is the Kratos engineer for North America, and he keeps that instrument running for me. He also is at present, it's an old Unix computer system. He's constantly upgrading it all the time, and at present he's trying to turn the Unix system into a PC to make it more user-friendly, because all the students want to have a data version, electronic version of their data. Also, just down there, you'll see my newest instrument, which is still not new, but it's the newest one in the facility, and that's an Orbitrap, and that's housed in the biological mass spec facility, and that is managed by Zoran Minic. So it's important to have a very good university, and it's important to have state-of-the-art instruments. And if you don't get state-of-the-art instruments, then it's probably a good idea to have really good PIs that will try and get money for you through all the ways that we've heard in the last couple of days. So here's Paul Mayer, he's my director, and there's Maxim Berezovsky, who is the director of the biological facility. And it's their job, and they champion for us and promote us and try and keep the mass spec facility running. They do lots of work, and we're very grateful to have them. So these are the people, the nuts, that run the mass spectrometry facility. And there's Sander Monmouth. He maintains, repairs all the pumps, the computers, the printers, the internet issues, you name it, he mends it. And up in the top left-hand corner there is Clem Kazakov. I took over from Clem in 2013 after 18 months of training just to work that instrument that you see behind him, that magnetic sector. Next door to him is Sean. Sean came to us as a student. 8 years later, he's still trying to leave us. Lillian here, who you can see in the top right-hand corner, she has a very interesting job. She actually spends 2 days with me, 2 days with X-ray, and 1 day with NMR. And she basically has allowed me to spend more time developing methods, Elsie, looking at developing new experiments for students to use, and also to update and do some personal work of my own. I'm doing a course in anatomy and psychology, and just basically freed up my time to do and develop and improve what's going on. And you also see in the middle here is Zoran Minic. And so I want to talk a little bit about what Zoran does. So Zoran runs a biological mass spec. He has 2 Orbitraps from Thermo Fisher. These are state-of-the-art instruments. His mission is to provide the best mass spectrometry that's possible for the omics, so particularly proteomics and metabolomics. In particular, he has developed a method of nano liquid chromatography for nano electrospray, of which he is very proud of. And I recently just sent him an email going, how do you fancy doing some lipidomics as well? So as you can see, we do lots of omics, as well as the small molecule stuff that I do in the chemistry mass spec facility. So when I was doing this, I had great fun putting this together, and I got all these photographs, and I realized that we all got old. Okay, so up in this left-hand corner, there's Sam Monmouth, there's Paul, look, he's like in his teens there, and then John, and we're still around doing the same job. And basically, at any one point in the mass spectrometry facility, we have over 100 years of mass spec experience to help you. So the professors, really important to me. There's been hundreds of them, and this just shows some of the chemistry professors, and each one of them, I don't see professors, I see molecules and the stuff that they're interested in. And also now we have cross-appointed biology professors, and each one of them we help to characterize. We're a characterizing technique, and help them as much as we can. So they each bring molecules from pharmaceuticals, from organometallics, alkanes, alkenes, terpenes, evolutions of gases from catalytic processes, proteins, peptides. And I also train their students from undergrads to postgrads. And now this is the student. The students are really important. Often I don't even know who they are or what they look like. I just know their name on a piece of paper. But sometimes I get to know them personally and I get to get involved in their projects. I also run workshops and training sessions, and I run a course where I actually get the students into the lab using the instruments on a regular basis. And so does Durand. Durand runs courses on cleaning up your proteins. He runs courses on instrumentation and looking to run other courses besides that as well. So I'm going to tell you about some of these people and some of the little projects. And in the middle here, you can see my friend Sharon, who runs a coffee roasting business down in North Grenville. And we were looking for an experiment that we could train students in for analytical instrumentation course. And this guy here, Jackson, went down all the way to North Grenville and he watched Karen roast her coffee. He then brought it back, he ground it up, he measured the quantification of caffeine in different types of coffees. And he also used the solid phase micro extraction technique and the GCMS to look at the taste and the flavors and the smells of coffee. We're always looking to find experiments that we can bring students into the lab so that they're getting real experience in real situations. At the moment, I have a student in the lab who is a medical student. She joined during COVID, so she's never actually been to the university. She's very excited to be in the lab, and she is using a chiral column on the GC to look at the chiral molecules in essential oils. And she basically has taken the instrument apart and put it back together again. And she's having a ball and getting some really interesting results. So analysis, right? What do I do? What haven't we done would probably be quicker. We've looked at plants, we've looked at nuts, we've looked at roots, we've looked at corn, we've looked at canola, we looked at palm oil and transferring it into making it a biofuel, which is now used in the Congo to power hospitals. We've analyzed a small vial from the Erebus ship that was discovered underneath the Antarctic. We've looked at the pheromones on the backs of flies. We looked at cannabis before cannabis was even popular. We've looked at drugs. We've looked at a lot of drugs. We looked at drugs that came out of Africa that had only 50% of what they said they had in them. And this started a whole Gates project. And Sharon, you can see there in the map of Africa, went over to Swaziland and Ghana and collected drugs and posted them back to me. And I LCMS them to see if they actually had what they say in them. Because we looked at propofol. People were in Africa. They were given a dose of propofol halfway through an operation. They were waking up, and we looked at propofol, and it was 50% the concentration that it should have been. Drugs stay on the tarmac, and tarmac at the airports, and they biodegrade, and they aren't what they said they are. Did I mention I love my job? I have the best job in the world. So I had to be fast. Challenges. I have pretty much the same challenges that everybody else has had. I have an interesting one that I've seen other people have as well in the chat, is that a mass spectrometer is often priced at about what a professor can afford. So a lot of professors will buy instruments and they will keep them in their labs. And one of my first jobs was to run around all of the labs and keep those instruments running. And I've gained a lot of instruments because they don't look after them after a while. That they train up a PhD student, the PhD student moves on, and the instrument is left. So I've gained a lot of GCMS that way. LCMS, not so much. They tend to not be reusable. And so when I come to put in a grant, take for instance, I need a new moldy. There is a moldy already in the department that's being used for a specific purpose. So therefore I can't get another moldy because of there's already one and it can't be used in the same way. So yeah, thank you. Thank you very much for listening. I hope that gives you just a quick, brief idea of what we do in the lab. And I hope I've highlighted to you that it really isn't me. There's a whole team of us doing the best that we can at all times. Thank you.
Thank you very much, Sharon. Yeah, it's obviously a labor of love. And we do tend to talk all the time about the instrumentation. So it's kind of nice and refreshing to see you focus so much on the people themselves.